Hello, I'm Don Fleming, the ARID Program Manager for 21st Century Systems. Today we're going to show you our initial demonstration of the ARID system. ARID's an acronym for Agent-Based Reduction in Information Density. This demonstration is a high-level view of ARID's principles and operation. Currently, the UAV operator receives a large quantity of data that clutters the display, and it's not translated into actionable information needed for the mission. This overload of data can be overwhelming and adds greatly to the operator's workload. Situational awareness is difficult to maintain, particularly with multiple UAV missions in play. ARID provides the automation to dramatically offload data that is not mission-centric, and this adds to the situational awareness and reduces the operator workload. The ARID system provides the means to fuse all incoming data. Then, using the operator-provided mission profile, along with ARID's ability to provide evidential reasoning that captures intent and relevancy, ARID provides the operator with an uncluttered display that focuses on the mission's intent. Situational awareness is greatly improved by shaping the flow of visual information and providing an uncluttered tactical display. ARID makes a measurable difference and increases the ability to control simultaneous operations of many UAVs. Now I'm going to turn the demonstration over to Jordan Nelson. Jordan?
This demonstration covers a scenario where the operator has two Predator drones to monitor and control. The mission goals are surveillance to counter placement of improvised explosive devices, or IEDs, monitoring friendly units to warn of approaching hostile tracks, monitoring predefined areas of interest for inbound traffic. A final goal, somewhat independent of the mission, is to maintain the health and safety of the UAV. Primary issues of concern are avoiding mid-air collisions, avoiding threats to the UAV, and staying within the mission boundaries. Mission boundaries consist both of restricted airspaces and the external boundary of the mission area. Let me define the mission area. We will be operating over the Yuma Proving Grounds. We expect heavy traffic over the north-south road here, some light traffic over the east-west road here. There's an active airbase here, and we expect some air traffic to be crossing our mission area. To the north, there's a staging area used by friendly units patrolling the roads. The mountain range in the northeast part of the mission area is tall enough to force a Predator out of its normal operating altitude. For the purposes of this demonstration, Predators will be controlled from within Falcon View by means of a drag-and-drop waypoint. This allows the operator to control a large number of Predators with a minimal effort. When I start the scenario, the simulator will start populating a gig channel. The Global Information Grid, or GIG, is a communications channel currently under development by the United States and NATO allies. Initially, I will be feeding this information directly into Falcon View. Later, I will show how the scenario looks with ARID's decluttering system enabled. Let me briefly explain the iconography we are using. This red diamond icon here represents a presumed hostile land track. The circle with a cross through it here represents a Predator. As you can see, its waypoint is set to take it northeast, closer to the main road. The yellow clover-shaped icon here represents an unknown, presumed neutral ground track. These are the vehicles traveling the roads. The red polygon here denotes the restricted airspace around the airbase. The other red zone, this circle here, represents a restricted area around a tethered weather balloon. The sun in the sky icon, shown here, represents the weather report issued from the weather balloon site. This turquoise rectangle here represents a friendly land track. The turquoise half ellipse here represents a friendly helicopter. As you can start to see, there is an airlift leaving the base. The final zone to the north represents an area of interest surrounding the staging area for friendly units. Now that we have a basic understanding of what the icons are, I want to cover what the operator needs to be doing. As the operator, I would need to be watching all traffic on the road, maneuvering my Predator such that I can quickly provide eyes-on coverage for stopped vehicles. A stopped vehicle may be as simple as a flat tire, or it could be a team planting an IED. We want to have a Predator on station close enough to get a good look at what any stopped vehicle is doing. Identifying stop tracks is somewhat difficult without zooming the map in close to the road and losing awareness of the greater mission area. It is important for me, as the operator, to have a sense of the entire mission area, because I need to be avoiding the incoming airlift, as well as keeping an eye on the situation where hostiles are approaching friendlies on the right-hand side of the map. I will now show what the same mission would look like with ARID enabled. What becomes immediately apparent is a stop track near the center of the map. I will assign a Predator to investigate it. Now you will notice the situation rapidly developing in the upper right of the map. The agents have a high certainty of a hostile approach on a friendly, causing the track icons to rapidly increase in intensity, drawing the operator's eye to the situation. I should point out that none of the ground tracks have been hidden from the operator. The known tracks that are not currently of interest to the mission are shown at a low intensity, leaving them visible but not distracting from the mission. The other elements, such as restricted airspaces, weather reports, and the like, are only shown when they are expected to have an impact on the mission. The airlift moving north is currently shown at a low intensity because it is currently too far away and outside the planning horizon of the mission.
The ARID system, as demonstrated today, is a collection of two agents that feed the visualization engine. The two agents are the Blue Force Sentinel, which watches friendly objects for approaching hostile tracks, and the Counter IED agent, which looks for stopped vehicles in major roads. In the context of the ARID system, agents are pieces of software that are characterized by the following properties. Agents are simple. An agent embodies only one, or at most, a handful of rules and/or heuristics. Agents are social. They cooperate and communicate with each other via XMPP and Jabber. The agent-based architecture allows for flexibility in the ARID system, with the capability of easily adding later agents as technology evolves and/or new missions are defined. In contrast to agents, an engine, such as the visualization engine, is characterized by significant complexity and tighter integration within the system. What we have just demonstrated includes only part of the planned functionality of ARID. Our next demonstration will operate in real time, with live data being processed by multiple agents, with each agent emitting judgments about one or more aspects of the current and projected situation. The next demonstration will also employ the ARID Fusion engine to gather the individual judgments and fuse these judgments into a single coherent summary of the relevancy of tracked objects, inferred relations, and projected events.